So let's take a look at these math notes boxes that show up throughout our CPM curriculum. It always contains key ideas and important information. And if we were in the classroom, this would be a resource that you're allowed to use on quizzes and tests. Of course, during our remote learning, we have a little bit more of this open book type model, but this is where key information is stored. So the first math notes box on 1.1.1 talks specifically about functions. What are these special relationships that we actually call functions? So we know that inputs and outputs we would call a function if there's exactly one output for each input, meaning you give me any x value, you give me a number to plug in for x, and there is only one possible output. And we're used to seeing equations written in y equals form, and you'll see in a little bit we have some special notation just for function. When it's written as y equals, we know that x is the input and y is the output. This specific example is a function, and what you would know, how you would know it's a function, there's a number of different things. Number one, if we look at the table, you can give me any x value, and there's only one possible y value. If we found a number if we found an input of -2 somewhere else on this list, and it had a different y value than what we had here, than the 16, then we wouldn't be able to call it a function. When the input were -2, we have to know that there's just that 16 as the output. If we're looking at a graph, one of the ways we know that this is a function is if 2 points have the same input but different outputs, they show up on the graph as above and below each other on the same vertical line. So a quick way to check a graph is to make sure, we often call it a vertical line test, but we want to make sure there are no 2 points above and below each other. So if you run a vertical line or a pencil across the graph, as long as it only ever hits your graph in one place, we know that that is a function. And this brings us to this idea of dependent and independent variables. The value of y depends on x. Whatever number we plug in for x, that's going to tell us what y is. We call x the independent variable, and y is the dependent variable. And a lot of times if we have values in a context, a situation in the real world, sometimes it's easier to know what's dependent and independent. If you're doing a lab where you're changing the amount of water you give a plant and you're measuring how much it grows, the independent variable is how much water you're putting into the plant because you're choosing that value. It's what you're controlling. The dependent variable, or the output, is how tall the plant grows. That's what you're measuring. So function notation looks like this, right? F of x. And anytime you see an equation that's written as f of x or g of x or h of x, that notation, we automatically know it's a function. We don't have to see the table. We don't have to see the graph. You only use that notation with functions. So here's this function on the right, and this function machine notation, which we sometimes use. You can see that f of 5, or when the input is 5, we plug 5 in for x and simplify it. 5 minus 2 is 3. 3 squared is 9. Our output is 9. The other thing that's nice about function notation, where we have f of 5 equals 9, is it allows us to see that the input was 5 and the output was 9. Right? When we just have x equals 5 or y equals 9, we can only see one of those at a time. So all of those inputs we call the domain, all the possible x values, and all of the outputs is called the range. X values for this particular example, we could put any number we wanted in for x, any of them will work. So that domain is all real numbers. Outputs, however, are only 0 or above positive numbers. So we would describe that output, or the range, as y is greater than or equal to 0. Here's an example of something that is not a function. X squared plus y squared equals 1. That makes a circle. We know that from geometry. And we can see from the graph that there are multiple points above and below each other. And if you look at the table, if I told you the output is 0, if I told you the input is 0, there are 2 possible outputs. Definitely not a function. So that's our little summary of functions.